Hello, this is Untitled Chapter. In this video, I'm going to show you how to use the agent avoidance component to make the agents avoid each other. So I provided a simple lever with a single agent group and with a grid layouts in machine behavior. So if I press play, you see the agents are colliding each other. So to make avoid each other, we need to add the agent avoidance behavior. This behavior can use different algorithms. So one is the time to collision, and that is a simple time collision check. It's simple to compute but doesn't give you the nicest simulation. Then we have the RVO, that's similar to the real one. Then we have the PedVO, that's a modification RVO made it specifically for pedestrian, like in this case with our human. And then we have the RVO 3D, that is used for agents are moving the full 3D space, like insects, spaceships, and so on. So they are not restricted to 2D environment like this. In this case, PedVO should be fine, and then we can tweak all the parameters for the PedVO. So we have the time horizon. So the time horizon, this one is the time used to check the colliding agents. So if you increase this value, then the agents start to tow when the obstacle is more far from the agents. If you decrease this value, then the agents start to tow when it's nearest the colliding agents or the colliding obstacle. And this one is the same thing for the obstacles. So this one, the obstacle are not other agents but the actor in your scene. Then we have the distant neighbors, the PedVO RVO, and also the time collision. Basically, all the algorithms use check the neighbors to compute the new velocity based on trajectory of the neighbors. And this one, in this case, for each agent, check all the other agents are a distance less than 400 units here. In this case, probably we can decrease to 250. Then here you can set the maximum number for neighbors to use to check the neighbor agents, and then the radius multiplier. So basically, the PedVO RVO, also the RVO 3D, use a second radius that is the smallest distance from the agent. They guarantee that other agents never enter in this radius. We can set up this radius from the agent type. If we go on the agent type, there is this radius here on the collision. So it's the same radius used by the agent collision component. And if you want to see that radius, you can turn on the debug. Press simulation. If you see is the dotted line around each agent, you can see it guarantees that each agent never enter inside that radius. Okay, let's have a look to the other parameter. Then we have the radius multiplier. Just it's a multiplier on top of this the radius on the agent type. Then we have max turn angle. So this is the max turn angle in degrees that each agent can turn on each tick. Then we have the max velocity. So since the PedVO RVO can change also the position, also the velocity, this one is the max velocity that agent that the agent avoidance can use to move the agents. And then the velocity threshold. So this threshold is used to deactivate one agent from the agent avoidance system. So for example, if you have an agent that's it's in an idle, or this move, you don't want to turn the agent based on the neighbors because it's an idle. So it has a velocity, in that case, a velocity of 0. In this case, all agents that has a velocity less than 0.5. This module doesn't compute the new velocity for that agent. And then we have the stride factor that are stride factor turning bias that are basically really specific to PedVO and RVO. Try to stick with this value. If you want, you can experiment a bit on this value. If you want to know what this value does, basically check the algorithm. But usually this value should be fine. And then we have the scene scale. So if one scale, since the PedVO, especially the PedVO, but also RVO are based on real units, you can, and your scale is different from like human scale. You can change this scale to have a better simulation. The other thing is the steps. So you can tell the agent avoidance to do multiple steps to compute the final velocity. Usually this one will smooth the rotation and increase also the stability. So you can start from 1 and increase, obviously more steps, and this if you have more steps, that obviously the module take more time to compute. Then this one, the agent groups, is for colliding, taking consideration also other agent groups. And then a navigation mesh, here you can take in consideration the walls of a navigation mesh inside the avoidance compute. Final things is dynamic obstacle, so you can add a dynamic obstacle to the avoidance simulation, and you can add here, so you can add no other actor here. So let's have a play with some other attributes. So you see right now it's already working, so we have no intersection anymore. Let's have a look to the parameter that you can use. Let me turn off the debug. So one thing, for example, if you have a navigation mesh, you can use that. For example, let's create some cube here, and one here, I don't know, one here, and then let's create another mesh. Let's increase the area. It's fine. Then we can set up the num mesh. Okay, when I press play, the agent should avoid the num mesh, as you can see here. Okay, now let's have a look to the other agent group that you want to take in consideration for the avoidance. So let's go back to my grid layout. Let's remove the random direction, and let's move this one a bit. Let's duplicate this one and change direction. Okay, if I now press play, you see the agents are basically colliding each other, because we need to tell each agent group to take into consideration the other one. So to do that, go to the agent group, agent avoidance, add an agent group here. In this case it's 1, so 1 collide with the agent group 2. At the agent group 2 it's the same agent group, but it's 1 is the agent group 1. So if I press play, you see now basically they are avoiding each other. Obviously, if you want the agent go on this direction, put, I don't know, a follow curve here, follow curve behavior, and add before the agent avoidance. In this way, the agents are forced to go there, but also avoid the other agents. So basically, that's it. Thank you for watching, and see you in the next video.